I am Anil Kumar. Welcome to my series on trigonometric ratios. Till now, we have seen how to calculate the trigonometric ratios for angles between 0 to 90 degrees. Now we have extended it to any angle. The most important concept which you need to understand is the concept of reference angle, also known as relative acute angle. So if you are in a position to find the relative acute angle or the reference angle, in that case, you can always evaluate the trigonometric ratio as you did earlier, because now you're again working with an angle which is an acute angle. So in this particular video, we will understand first what really is a reference angle, sometimes also called as relative acute angle. And then we have some related questions. Question number 2 is explain the strategy to calculate trigonometric ratio with reference angle. Now, this strategy really works for any angle. Question number 3 is express the following in terms of trigonometric ratios of acute angle. So, a process in which we are going to find the value of trigonometric ratios is being shown with the help of the examples here. Question number 4 is find the angle theta, where theta is between 0 to 360 degrees for cos theta equals to minus half. Question number 5 is find the angle theta, where theta is between minus 360 to plus 360 for cos of minus square root 3 over 2. Question number 6. Evaluate exact value of the following trigonometric ratios. And 7 is, given theta is an acute angle, express the following in terms of sine, cosine, and tangent. So these questions will help us to understand the concept. So let's begin with the very first thing, that is to understand what, after all, is a reference angle, also referred to as relative acute angle. As the name suggests, when we say relative acute angle, it means acute means less than 90 degrees. So this angle theta is actually less than 90 degrees, and we are always taking this as positive, so it is from 0 degrees to 90 degrees. That is the reference acute angle. So we could define this reference acute angle as the acute angle alpha, which the terminal arm in standard position forms with the horizontal x-axis, is called as a reference angle. It is always less than 90 degrees, and the value of all trigonometric ratios for the reference or related acute angle are positive or is positive. What I'm trying to say here is that if I have a coordinate plane, then angle in standard position, the term used here is standard position. It really means that the initial arm is along the positive x-axis, and then we're going to rotate this to form an angle, correct? So when you rotate it, then you get the terminal arm. So we have these two arms which are called initial arm and the terminal arm, right? The acute angle which we are talking about is the angle which is made between the terminal arm and the x-axis. So this is the angle which we are talking about. So this angle will normally refer to this angle as angle alpha. So now I think the definition makes more sense. It says the acute angle alpha, which the terminal arm, so this is your terminal arm, right, in standard position forms with the horizontal x-axis. Is that clear to you? So if the angle is in quadrant 2, as you've seen here, in that case that will be a reference angle. Well, let me sketch another drawing here where the terminal arm could be, let's say, somewhere there. In that case, the reference angle is this angle. That is the reference angle we are talking about. So we have to always find the reference angle to find the trigonometric ratio. Correct? Now, you know what reference angle is, so question number 1 is kind of answered. However, we have to still look into the strategy, how that helps in calculating the value. Well, as you can see, I've shown some drawings here which says the point, the terminal arm could be in quadrant 2, could be in quadrant 3, could be in quadrant 4, or in just quadrant 1. In any case, the angle which the terminal arm makes with the horizontal axis we are referring to as alpha. So what you will notice here is that trigonometric ratio of alpha is always same. The sign could be different. You get the idea, right? So what I'm trying to say here is something like this. So if I have, let us say, sine of 30 degrees. So sine of 30 degrees is half, right? You can make a special triangle and figure this out. Let's make one here. So in this particular special triangle, the sides are 1, 2, square root 3, and the angle of 30 degrees is right there. Opposite over hypotenuse. Okay. What is sine of 180 plus 30, which is 210 degrees? Well, that is also half, but with a negative value. You get the idea. So what I'm trying to say, if that is the case, in that case, we'll end up in quadrant 3. In quadrant 3, sine is negative. Well, we know this from the cast rule, correct? So this particular diagram here tells you in which quadrant what is negative and what is positive. So basically, combining the cast rule information which is shown here, we know that sine is only positive in two quadrants. In quadrant 1, all are positive, and in quadrant 2. So the value of sine of 30 degrees will be half. 210 is minus half. If I take, let's say, 360 degrees minus 30 degrees, then the value still will be half. However, since we are in quadrant 4, it will be negative. So actually speaking, what you notice here is that if the angle alpha is same in any quadrant, then the value, the absolute value is always same. However, the sign is decided about the position of terminal arm in a particular quadrant. Perfect. So basically, combining with the cast rule, or you can say ASTC, we can find when what is positive and give it a sign. Perfect. I hope that makes sense. Right? So that is how we could work. Let me add one more here, which is sine of 180 minus 30 degrees, which is 150 degrees. It will be just half, since you are now in quadrant 2. But in all the cases, for angle alpha equals to 30 degrees, what you noticed is that if you are making an angle alpha that is 30 degrees, in this case of our example, then the absolute value of sine of 180 plus minus alpha is actually half. Perfect. So it remains same. Now, whether it is positive or negative is decided with the cast rule. Okay? So that is the concept. So that is how it helps to evaluate the correct answer for any angle. Let's take some examples to understand this concept in greater details. So I have here my quadrants, quadrant 1, 2, 3, 4. All are positive in quadrant 1, sine in quadrant 2, and in quadrant 3, tangent is positive. In quadrant 4, cosine is positive. So you could learn this as all students trust Canadians or the cast rule. Well, C starts with quadrant 4, creates confusion at times. Okay, question number 3 here is, express the following in terms of trigonometric ratios of acute angle, right? That's the question. So what I'll do here is to really understand the situation, we'll actually sketch each and then write down our answer. So sine of minus 30 degrees. Initial arm is right there. Minus means we go negative and that's it. So sine of minus 30 degrees is right there. What we notice here is that the acute angle alpha is 30 degrees. So we can say sine of minus 30 degrees is equal to sine of 30 degrees. But what is the actual sine? We can apply the rule. All are positive here. Sine is positive in quadrant 2, tan and then cosine. Since sine is negative, we'll put a negative sign here. So we can express the following in terms of trigonometric ratios of acute angle as this equal to minus of sine 30 degrees. Does make sense to you? Since it is in quadrant 4, the value will be negative. Correct. Let's take the next example, which is cosine of 170 degrees. Now 170 degrees is slightly less than 180. So you are in quadrant 2. In quadrant 2, sine is positive, not cosine. So here you get a value which is minus because you are in quadrant 2. The acute angle here is what? Acute angle is 10 degrees. And therefore, it is minus sine of 10 degrees. Does make sense to you? Oh, sorry, cos. We're working with cos. So minus cos of 70 degrees. So you could write here that cos of 170 degrees, sorry. Now, in this particular case, you know that the acute angle alpha is equal to 10 degrees. You are in quadrant 2 and therefore cosine is negative. And so we can write down cos of 170 degrees equals to negative cos of 10 degrees, which is the related acute angle alpha. Is that clear to you? Now let's take the last example, which is tan of 500 degrees. Now when I say 500 degrees, we will go 360. And then how much more? So we can do 500 minus 360 and we get 100. It takes away 140. So we land up here right there, right? 140. So when we land up at 140, the terminal arm is in quadrant 2. Tangent is negative here. What is the related acute angle? Let's figure this out. Well, the related acute angle is 180 minus 140, and that gives you 40 degrees. So the related acute angle is 40 degrees. Since we are in quadrant 2, tan is negative, we can write tan of 500 degrees as equals to negative tan of the acute angle, which is 40 degrees. Does it make sense to you? So we could always write any angle and then the trigonometric ratio of that in terms of its acute angle, the sine being decided by the cast rule, and the position decides what the angle with the horizontal tells you what the acute angle is, and the answer will always include an acute angle as we see here. So there are two parts to it. One is the sine, which you get from the cast rule, and the other one is the acute angle, 180 minus the angle. Perfect. Let's take more examples. Question number 4 here is, find the angle theta when theta is between 0 to 360 degree for cos theta equals to minus half. Now, let's try to understand the situation. We are given the cos value as minus half. So let's write down here. So we are given cos theta equals to negative of half. Now negative means that we are in quadrant 2 or in quadrant 3. Correct? Since we know that all are positive in quadrant 1, sine in 2, tan in 3, cos in 4. So negative really means that the terminal arm could be either one of in these two quadrants. Now for half, what we could do is we could actually make a special triangle. So our special triangle 30, 60, 90 works. So we get 1, 2 and square root of 3. For cos being half, we are looking at 60 degrees. Is that clear to you, right? So we know that the acute angle is 60 degrees. Now, we need to find the solution of this equation, which is when theta is between 0 to 360 degrees. That means that I could actually extend this and see that in these two quadrants, what is the acute angle? Well, in these two quadrants, the acute angle is 60. Correct? And therefore, what is the principal angle? The principal angle is 180 plus 60 or 180 plus 60. 180 minus or 180 plus 60. So we get the angle theta as 180 degrees minus 60 degrees, which is 120 degrees, or the angle theta as 180 degrees plus 60 degrees, which is 240 degrees. Do you see how we got the answer? Right? So without calculator, we can easily get this answer. So remember one thing, let me put this as a note, as calculator will provide only one solution, right? It will never provide two solutions, correct? That is one thing to remember. Calculator will provide only one solution. Second, most important here is that it may not be in your domain. So that doesn't work. So we have to understand the acute angle concept. So that is where the acute angle helps. Perfect. This is extremely important to understand. Right? In fact, if you do cos inverse of minus half, you will get one of these answers. Right? You may get this answer, but not the other one. So you have to use the concept of acute angle to find all possible solutions. Is that clear? Right? Let's take another example to make it more clear. Now this time what I've done here is I'm saying find the angle theta, but I've extended the range of my angle. So I'm saying between minus 360 to 360. So once again, I have a very similar example. So I'm saying that cos theta this time is equal to minus square root 3 over 2. So when I say minus square root 3 over 2, we know the coordinates and let's find the angle also. As far as angle is concerned, we will have the angle as 30 degrees. Correct? So we know the acute angle alpha is 30 degrees. Does it make sense? So what we find is we find related or we find the reference angle. So we say, well, alpha is cos inverse of square root 3 over 2 and the answer here is 30 degrees. You get the idea, right? So we only calculate the reference angle. And now we apply our concept and we say, well, we are looking into the positions in quadrant 2 and 3 since we have a negative value, right? Since we have a negative value, we are saying it is in quadrant 2 or in quadrant 3. And the acute angle which we're talking about is 30 degrees. So what are my answers? Well, one of the solution, of course, is right there, which is 180 minus 30 degrees, which is 150 degrees. The other one is theta equals to 180 plus 30 degrees, which is 210 degrees. So we have covered this portion of our range. How about the other one? We could take away 360 degrees, right? So we could go in the reverse direction, that is kind of like that, going backwards. Do you see that part? Right? So that gives you one of the angles, right? So we get theta equals to minus 180 minus this, which is minus 150 degrees, and we get theta equals to minus 210 degrees. So we get all the solutions, and our answer now includes four solutions. Theta equals to plus minus 150 degrees or plus minus 210 degrees. So you see the application of the related acute angle, it really helps to find all possible solutions within a given domain. Now let's take more examples. Question number 6 here is, evaluate exact value of the following. So I'd like you to pause the video. I've given some hint here with beautiful drawings that should help. The question here is sine of minus 135. So let me write down here. We want to find what is sine of minus 135. So 135, I've tried to sketch it here, which is, as you can see, falls in quadrant 3. So in quadrant 3, it is negative. We find that with the cast rule, right? Or you can say ASTC. All silver teacup, all students trust Canadians, or the cast rule. Since you're now in this quadrant and here only tan is positive, sine is negative, find the related acute angle. Acute angle is 45 degrees. So we could write this as sine of 45 degrees. Now look into the special triangle of 45 degrees, which is drawn here, which you know. You can now evaluate the value and you can write down the answer, which is minus 1 over square root 2. Normally written as minus square root 2 over 2 after rationalizing. Correct? That is how you have to do it. Next one is cos of 240 degrees. That means we are saying cos of 180 degrees plus 60 degrees. So the related acute angle is 60 degrees, right? You are in quadrant 3, so the cos is negative. Correct? So that gives you a negative value. So therefore, we get this as equal to minus of cos of 60 degrees. Looking into the special triangle 30, 60, 90, which had been drawn so many times before, we know the answer. Cos of 60 degrees is half. So we get minus half as our answer. Clear? The last one here is tan of minus 210 degrees. So when you go back in the clockwise direction, you land up here in quadrant 2. In quadrant 2, tan is negative. The acute angle here is 30 degrees, correct? So you could write this as minus tan of 30 degrees. Using a special triangle, tan is, this is your 30 degrees, 1 over square root 3. Rationalize to give you the answer of square root 3 over 3. Is that clear to you? That is how we can easily find the exact value of trigonometric ratio of any angle. So related acute angle or reference angle helps. Now, almost at the end, this is the last question for you. Question number 7 is kind of a review. Given theta is an acute angle, express the following in terms of sine theta, cos theta, or tan theta. So basically, you need to use the cast rule and the reference angle. So let's begin with the very first one, which is sine of 180 plus theta. So it is sine of 180 plus theta. So if you sketch this, 180 plus theta will happen to be here, right? So that is the angle theta, and this is 180. Do you see how it works? So the related acute angle alpha is equal to theta, and you are in quadrant 3. Using the rule, in quadrant 3 sine is negative, so we'll write this as sine of 180 plus theta equals to minus sine theta. Is that clear to you? That's so simple. Let's do the next example, which is cos of 180 minus theta. So we are saying cos of 180 minus theta. So that means now you are in this quadrant, quadrant 2. Cos is negative, so it is negative of cos theta. Is that clear to you? So simple. The last one here is again cosine function, but this time it is 360 minus theta. So when you do 360 minus theta, you are coming right there, right? So this is 360 minus theta. Theta is an acute angle. You are in quadrant 4, and quadrant 4 cos is positive. So you will write this as cos of 360 minus theta in degrees is equals to positive cos theta, since you are in quadrant 4. Perfect. So let's do the next three. I'd like you to now do these and write down the answers. So we have the very first one, which is sine of 360 degrees minus theta. We are in quadrant 4. So it is negative sine of theta. Perfect. Since we know the cast rule, which actually C is in quadrant 4. And in this particular case, since we are saying 360 minus theta, we were in quadrant 4, correct? So that was your theta. Sine is negative. Next one here is tan of 360 degrees minus theta. So basically, again, what we are doing here is we have an angle theta here. Now from this, we are doing 360 degrees minus theta. That means you go like this, 360 degrees, and take away theta. So you land up in this position, as we did earlier. Tan is also negative here, so it could be written as negative tan of theta. Correct? So that is how we are going to get the solution. As such, also, we understand tan and sine are odd functions. So let me introduce you this particular concept, which most of you know. They are odd functions. And so we also know that sine of minus theta is minus sine theta. And also we have tan of minus theta, let me write here, equals to minus tan theta. Correct? The cosine is actually even function, okay? The last one here is, we'll write down here, sine of, we're doing this one now. The last question, sine theta minus 180 degrees, right? That's kind of tricky. So how do you do this? Theta minus, so basically what has happened here is that, let's say this is the acute angle theta. Now, from this acute angle theta, you minus 180 degrees. So from here, when you do minus 180, you'll end up here. And you can see that the acute angle is theta for you. The angle made with the horizontal x-axis. But you are in quadrant 3, and therefore this should be minus sine of theta. Clear? So it's so simple as that. You have to figure out just the quadrant in which you are, give that sign using the rule, which is the cast rule, and the same value of theta. That helps. So, you've seen in this particular exercise how, using the reference angle, we can easily evaluate the value of a trigonometric ratio. For ease, we took exact values using the special triangles, but any angle could work. I hope that makes sense. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.